Hello students, I hope that you are good, well and fine. In today's session, we will be seeing the remaining problems of exercise NCERT exercise 7.5. Okay, so far we have seen problem number 1 to 7. Now we will be trying to see the solution for the remaining problems. Okay, so let's jump to our first problem in today's session, or the eighth problem of this exercise. So we have to evaluate the integration of this. Okay, so quite simple. So what you have to do is let this given expression, okay, so let this given expression, okay, is equals to a by x minus 1 plus b by x minus 1 square plus c by x plus 2. Okay, now after simplifying, you will get this as your expression. Now in order to get your a, b, c values, put x is equals to 1, you will get b value. Now comparing what you have to do, now equating the coefficient of x square, okay, equating the coefficient of x square in constant term, you will obtain what? You will have a plus c equals to 0, and another expression will be minus 2a plus 2b plus c equals to 0, and you already know b value is 1 by 3. So from this you can easily say a is equals to 2 by 9 and c is equals to minus 2 by 9. Simple. This means your expression is now changed into partial fraction of this form. Clear? Now you can easily evaluate the integrals as what? This integral is just nothing but log of modulus x minus 1. This integral is just nothing but what? Using the power rule, you can directly say that minus 1 divided by x minus 1. Okay, and this integral will be log of log of modulus x plus 2. Okay, clear? So the final form or the final answer will be in this form. I hope it is clear. Let us move to the next problem. Problem number 9. So 3x plus 5 divided by x cube minus x square minus x plus 1, you have to evaluate. Okay, so far so good. Now as you can see, denominator can be reduced to this form: x minus 1 whole square multiplied with x plus 1. Okay, now this means what? This means now you can apply the corresponding partial fraction. So you will get what? You will get this. This means simplifying it further, you will have expression like this. Okay, now what? Now substituting x is equals to 1, you will get the p value, and b value will be just 4, as you can see. Now what you have to do? Now simple, equating the coefficient of x square and x, you will get these two equations. Okay, from second equation, putting b value, you will get c value. So c value will be half. And now if you get c value, you can, from the first equation, you can get a value will be minus c, which is minus half. Okay, now this means your original expression reduced to partial fraction form, which is this. Now you can easily integrate it. So integration of this will be what? Log modulus x minus 1. Integration will be this what? Minus 1 divided by x minus 1. Okay, and integration for this will be log modulus x plus 1 plus some constant. Always add plus some constant term. Okay, so you will have the final form using the properties of log. This will be your final answer. Okay, clear? And let us see the 10th problem. Now 10th problem says this. So reducing it into the corresponding partial fractions. So you will have what form? A by x plus 1 plus b by x minus 1 plus c by x minus 3, x plus 3, 2x plus 3. Okay, on simplification you will get this expression. Okay, and now what? Now as you can see, okay, so in order to get your a, b, c values, what you have to do? In order to get your ABC value, what you have to do, what we are trying to say is that equate the x square coefficient and x coefficient and also the constant terms, you will get what? B is equals to minus 1 by 10, A is equals to 5 by 2, C is equals to minus 24 by 5. Okay, clear? And from here what you can say, yeah, now your partial fraction form will be this for the original given fraction given rational function. Okay, now as you can see, this can be reduced to this form. Okay, and now you can easily find or evaluate your integral. So this integral will be log modulus x plus 1, log modulus x plus 1, and this will be log modulus x minus 1, and this will be log modulus 2x plus 3 divided by 2. Okay, as you can see, the final version or the final answer will be this. Okay, after doing the necessary manipulations. Okay, let's see the 11th problem. Now 11th problem can be reduced into this form: a by x plus 1 plus b by x plus 2 plus c by x minus 2. Clear? Simplifying this, you will get this as your expression. Now substituting x is equals to minus 1, you will get a value. A value will be 5 by 3. Substituting x is equals to minus 2, you will get what? B value. B value will be minus 5 by 2. Okay, B value will be what? Minus 5 by 2. A value 5 by 3, and substituting 2, you will get 5 by 6 value, because every other term will be eliminated directly. Now your partial fraction form will be this. Okay, now integration will be quite simple. The integration for this will be what? Log of modulus x plus 1, log of modulus x plus 2, log of modulus x minus 2. Okay, the answer will be this. I hope that it is quite easy to answer the question. Okay, so let's see this. Now this is not proper. Okay, as you can see, this is not proper. This means we have to change it into proper. So how you are going to change it into proper? Quite simple. Dividing x is dividing this numerator by denominator, you will get what form? You will get this form: x plus 2x plus 1 divided by x square minus 1. Now change this form into the partial fraction form, corresponding partial fraction form, and the corresponding partial fraction form will be a by x plus 1 plus b by x minus 1. Now simplifying it, you will get this. Substituting x is equals to 1, you will get b value as 3 by 2, and substituting x minus 1, okay, x minus 1, you will get a value which is half. Simple. Now this means your partial form or the original expression now reduced to this. Okay, this means now you can directly find the integration. So integration for this term will be x square by 2, as you can see. For this term it will be half of log modulus x plus 1, half of log modulus x plus 1, and for this it will be 3 by 2 log modulus x minus 1. Okay, plus some constant, always at some constant. Clear? Let's see problem number 13. Problem 13 says this. So reduce it into the corresponding partial fraction form. The corresponding partial fraction form will be this: a by 1 minus x plus bx plus c divided by 1 plus x square. Okay, now simplifying it, you will get this. Okay, and on comparing, what you will get? Compare x square coefficient. Okay, you will have a minus b equals to 0, a minus b equals to 0. As you can see, a minus b equals to 0. Compare x coefficient, b minus c equals to 0. As you can see, b minus c equals to 0. Okay, b minus c equals to 0. Now compare constant terms: a plus c equals to 2, a plus c equals to 2, a plus c equals to 2. Now what? Now just add all of the equations. You will have 2a is equals to 2. This means a will be just 1. A will be 1. If a is 1, then b also 1 from the first equation. If b is 1, then c is also going to 1 using second equation. Okay, so this means you have now this as your corresponding partial fraction. Now you can directly find the integration very easily. Okay, what the integration of this will be log what? It will be what? Minus log of modulus 1 minus x. Oh, sorry. Yes. Okay. Clear. And for this, we have to use what? What you can use? The substitution method. The substitution method. Okay. After substituting, what you can get is log of half of log of this form. Half of log of 1 plus x square. Okay. And this is directly just nothing but tan inverse x. Tan inverse x and plus some constant. Okay. I hope it is clear to you. Now let's move to the 14th problem. 14th problem says integrate this. Now the corresponding partial form will be what? Partial fraction form will be a by x plus 2 plus b by x plus 2 whole square. Now simplifying, you will get this. Simple. Now from here what you can see, just compare the things. You will have x is equals to 3. This means, sorry, ax is equals to 3. This means a will be 3. Okay, a will be 3. Now constant term will be equate. Okay, so this will be 2a plus b is equals to minus 1. 2a plus b is equals to minus 1. You know the a value. This means b will be minus 7. Now the corresponding, okay, so this expression or this fraction you are given with the corresponding partial fraction will be this. Okay, now you can directly evaluate the integration. What? So 3 times log modulus x plus 2 minus 7 times. Okay, this will be a plus. So plus 7 times. Okay, you will have what? X by, sorry, 1 by x plus 2. Clear? I hope it is clear to you. Simple. Okay, now let us move to the next problem. Problem number 15. Problem 15 says integrate this. So let's see the solution quickly. So 1 by x power 4 minus 1 can be reduced to x square minus 1 multiply with x square plus 1, and this can be further rewritten as this expression, and the corresponding partial fraction form is this. Now we will be try to find a, b, c, d values using the comparing things. So you will have, after simplifying, you will have this. Now what? Now further simplifying, you will get this expression. Now taking x cube, okay, and comparing it, you will get a plus b plus c is equals to 0. You will get a minus a plus b plus d is equals to 0. You will get a plus b minus c is equals to 0. You will get a minus a plus b minus d is equals to 1. Okay, as you can see. Okay, if you add all of these equation, what you can get? You can see that a will be cancelled. Okay, you can see that c and d also going to cancel. Only you left with b. So 4b is equals to 1. This means b will be 1 by 4. So b will be 1 by 4. If b is 1 by 4, okay, if b is 1 by 4, then you can easily see what is happening. Then again put the b value and then do the respective operation. You will get a is equals to minus 1 by 4. Okay, a is equals to minus 1 by 4, c is equals to 0, and d is equals to minus half. So this expression now reduced to partial fraction of this. Now you can directly evaluate your integration. So I'm going to just tell you verbally. So it will be minus 1 by 4 log modulus x plus 1, as you can see. 1 by 4 log modulus x minus 1 and minus half. So this can be used a tan inverse. So minus half tan inverse of x, just it. So your final answer after using the log properties, you will get this as your final answer. Okay, clear? Okay. Now 16th problem. Okay, let's see the quick answer. So here the hint is already given. So let's see how we are going to use that hint. So multiplying in numerator and denominator by x power n minus 1. You will have what? This can be reduced to this now, this form. Okay. Now this thing can be rewritten as x in numerator x power n minus 1 and in denominator x power n multiply x n plus 1. Okay, now you can easily what do the substitution x power n t. This can be reduced to dt is equals to x power n minus 1 dx. Okay, also the n will be multiplied over here. Clear? Okay, this means what? X power n minus 1 dx is equals to dt by n. Okay, dt by n. Clear? Okay, so this thing, this integration now we rewritten as this, and this can be reduced to dt by n divide in denominator you will have t multiply t plus 1, and now you can use the partial fraction concept in this integral to evaluate this integral. So the corresponding partial form will be a by t plus b by t plus 1. On simplification, you will get this substitution t0, you will get a value, and substituting a t is equals to minus 1, you will get b value. Okay. So this integration, this term integration, now you can use the concept of partial fraction and you can directly evaluate the integration for this. So the original thing was this, you reduce that thing into this. Now this will be what? Log modulus t minus log modulus t plus 1. Substituting back t value, you will get minus 1 by n log modulus x power n minus log modulus n x power n plus 1. Okay, clear? I hope it is clear to you. Okay, so the final answer will be what? As you can see, so this is not, we don't the minus will won't be here. Okay, so using what? Using the properties of log, you will have just nothing but what? You will have 1 by n multiply with log of modulus x power n divided by x power n plus 1 plus some constant. Okay, clear? I hope it is clear to you. Okay, so now the 17th problem. Now 17th problem says this. So here the hint is already given that put t is equals to sine x. So using that substitution, what you will get is sine x is equals to t. This means cos x dx is equals to dt. So this means numerator can be replaced by just simple dt, and denominator now becomes 1 minus t and multiply with 2 minus t. Now this can be reduced to partial fraction. The corresponding partial fraction will be this. Now on comparing, you will have this. Substituting t is equals to 2, you will have b value which is minus 1, and substituting t is equals to 1, you will have a value which is 1. Okay, so this means this integration is now reduced to this form, and you can directly evaluate the integration for this. Integration for this is just nothing minus log modulus 1 minus t, and here plus log modulus 2 minus t. So after using the log properties, the final answer will be, after using the log properties as well as the substitution, you will get the final answer in terms of x as log modulus 2 minus x divided by 1 minus sin x plus c. Okay, so now let's see 18th problem. 18th problem says this. So first of all, reduce it into the proper fraction. You will have this as your form. Now the corresponding form will be what? Corresponding partial form will be this. Now on simplifying things, you will get this as your expression. Further simplify in terms of x cube, x square, x coefficients, you will get this as your expression. Okay, and on comparing you will get a plus c is equals to 0, b plus d is equals to 4, 4a plus 3c is equals to 0, and 4b plus 3d is equals to 10. Okay, so on solving, what you will get: a is equals to 0, b is equals to -2, c is equals to 0, d is equals to 6. Okay, now you can have what the integration of the original thing now reduced to this form, and you can directly what now you can easily find the integration, and you know the direct integration for them. You will have what? So first of all, you are having what? You are having integration here. Okay, integration. So for one, it is just x. For this, as you can see, you will be using tan inverse concept. So 1 by a tan inverse x by a. So a is just √3. Okay. Now here, what you are using the same tan inverse concept. So this will be what? A is what? 2. So 1 by a tan inverse x by a. So you will have this. Okay. So the final answer will be in this form. Now the 20th problem. So 20th problem says 1 by x multiply x power 4 minus 1. Okay. So let's see the solution quickly. Now multiplying denominator and numerator by x cube, you will have this as your expression. Okay. Now your expression will be this. Now this integration reduced to this form, and you can easily find by substituting x power 4 as t. Okay, so this will be what? A dt will be this. Now you can reduce your numerator by just dt by 4 and denominator by t multiplied t minus 1. Now you can use the concept of partial fraction to evaluate this integral. Using that, you will have this as the corresponding form, and by simplifying you will have this as your expression. Now substituting or comparing things, you will have a is equals to -1, b is equals to 1. This means this integral is now reduced to this form, and the integration will be what? As you can see, minus log modulus t and plus log modulus t minus 1. The final answer will be 1 by 4 log x power 4 minus 1 divided by x power 4 modulus plus c. Okay, clear? Okay, so okay, so that is it, as we are running out of time. Okay, so I hope that you understood every step, okay, or how we use the partial fraction concept. So you must know, the main important thing is you must know what? You must know the corresponding partial fraction form of any given expression. Okay, so if you do not remember, so don't worry, please refer to the theory session. We have already showed you that what expression gives the what corresponding partial form. Okay, so thank you for watching this. Okay, so we will be back with the more theory and the remaining problem of this exercise. Again, thank you.